as I've talked with you guys before, um, the reason that we've been doing all these little steps throughout the way, all these little bits and pieces, talking about what's the degree of the polynomial, talking about how many terms are in the polynomial, talking about how many different directions, how many times you can change direction, talking about the tails, talking about possible zeros, all that kind of mumbo jumbo, all leads us to this thing, the fundamental theorem of algebra. It is important. You know why it's important? It's fundamental. The you know how in your classes and stuff you guys have standards? There are certain things you're supposed to meet. You heard that? I'm sure you've all heard this thing called the Common Core nowadays. Well, there are specific standards to which certain math criterion meet, and everything we teach you guys has a purpose, believe it or not, and it is to eventually meet some of those standards. Well, this of all the high school math standards that there are, there's about 35, 40 of them or so. Just this one lesson encompasses about 14 of them. So the idea of why maths is kind of the big deal. And this is why everything that you have learned from being able to do this when you first learned how to do that, or even further back, okay, even when you go further and further back to stuff like that, the reason that math is because for every value of x, there exists some answer. So when you've been solving for x since you guys, I think the first time you guys solved for x when you first learned addition, probably about first grade-ish, second grade, actually kindergarten, I doubt you say that. Moose, our youngest son, he's in kindergarten right now. They're doing they do all the adding, and they talk about the numbers and stuff like that. So his name is Moose. Moose Ryan Murphy.
It's just a moose.
Yeah, Moose, we call him Moose. No, it's his name, Moose. So we, when he had his first math workbooks that come home, you have to trace the numbers and all that. One of the first things that they talk about is sequencing. 3 blank 4 5. Wait, sorry. 3 blank 5 6. That's that new math that they're learning over there right now. But it's the idea that they're trying to find the missing value. So what happens here is that they're learning the idea that for every value that you're missing, there exists an answer. That's what the fundamental theorem of algebra is. So like I said, here's all of these things. Yeah, I wasn't messing around, but this is why algebra. So when you think about what we've done so far with polynomials of the nth degree, if I have f of x is x to the fourth plus 4x to the third minus 6x squared minus 36x minus 27. When I look at that polynomial, that tells me a bunch of information. When we think about what we have done throughout this entire chapter up to this point, the very first thing we talked about was that versus that. Remember that? Remember that? Use the word that. We were talking about degree, nth degree, and its leading term coefficient. Well, what's the nth degree here? 4. Is that odd or even? Even. What's the leading term coefficient? Is it positive or negative? What are your tails? Up. Your tails are up. The first thing you learned about was graphing, doing dance moves. Okay? We did our dance moves. So we know that this has to be up. We know that it's a fourth degree polynomial. We know that it could change directions up to how many times?
After we talked about numbers of change to directions, we then said how many terms are in its sequence. What I mean by terms in sequence, how many pieces are in that polynomial? How many up to, how many can you have in there? 5. Remember, it was always n plus 1. When we're talking about nth degree polynomial, n minus 1 changes direction, n plus 1 terms in the sequence. So you can have up to 5 terms in this sequence. We also know that how many possible zeros? How many possible zeros can this have? It's going to have 4. It's a 4th degree polynomial, which means there are 4 values of x, which means you can have 4 possible zeros. The idea is, however many values of x you have, is how many zeros you have. If it's a linear equation, 2x plus 1 is 6, how many answers do you have? 1. If it's a quadratic equation, x squared equals 8, how many answers do you have? 2. If it's a cubic answer, how many zeros could you have? 3, and so on and so on. That's the idea. For every value of x, there exists a zero, whether it's real or imaginary. That's the fundamental theorem of algebra. Every x has an answer. That's why we solve for x. It's why every flipping thing you've done in every math class, solve for x, works, because it has to. There has to be an answer. You know, I don't know. Yes, sir. Yes, sir. I don't know. Let's just Google that. I think it was Euler. Euler. Sorry, Euler. I think Euler came up with it. That was around the 1300s.
I mean, the math stuff is
All right. All right. Well, what do we do here to fact? What do we do here to get our zeros? Let's find all possible zeros of that. We have x to the 4th plus x squared minus 12. And I want to find all possible zeros. Oh, wait. Oh, was that right? Was it Euler? It's pronounced Euler. I was close. A couple hundred years off. 1799?
Yeah, Euler had like something to do with it.
Yeah.
But like
It's just slippery down.
Yeah. So like the first proof of the fundamental theorem of algebra was given by Carl Friedrich Gauss.
Oh, Gaussian. Yeah, Gaussian.
And his PhD thesis. Yep.
He's a nerd.
Yeah. So like Euler had like something to do with it.
Yeah. Gaussian algebra is some crazy weird stuff. There's a lot of weird. I kind of remember being in that class in college, but I don't really remember being in that class. It's one of those like I think I got a C in that class. But I think I kind of showed up and was there. Seb probably helped me through it. He's a lot smarter than I am. All right. Remember the tricks? We've done this before. What was the trick when you had 3 terms and your degrees were cut in half each time down? The thing. What thing is that, Mackie? You factor, right. What times what's negative 12 you add together to get positive 1? Or negative 3. So I know that I can write this as x squared plus 4 and x squared minus 3. This then generates possible zeros. What are your possible zeros then? Or actually, what are your zeros? What are all your zeros? You get plus or minus 2i and plus or minus root 3. You have 4 zeros. 4 zeros, and when we say this, these are 4 zeros within the complex plane. The reason why I say it's the complex plane is because we're including complex numbers, which are your i's. So for any time you have an equation that has an x in it, there will always exist some answer across the complex plane that allows you to say what x is. Whether it's real or imaginary, you should get an answer. I believe root 3 would be, it's a real number, but I think it's irrational. Is that right? I always forget on how those are grouped. I've never figured that out. Yeah, it's something you talk about for a little bit here and there, but after a while it's kind of go.
I think just like real numbers are just like all numbers that aren't.
Yeah. What about this other one? F of x is x cubed plus 5x squared minus 9x minus 45. How do you want to set that one? That's forcing you, it kind of forces you to group. Do you have to group it? Because you synthetically divide if you want? Yeah. But wouldn't it be easier just to group it right off the bat? You know, and that's kind of the idea here, guys. Now that we've gone through a couple of different ways to set these things up, you're going to have decisions to make on your own as to which method do you feel like using. There's no rhyme or reason as to which one's better than another. But for something like that, if you pick up the idea that you have a group, why not group it? All right. So if I group this one, I have an x squared, x plus 5, negative 9, x plus 5. And where are your zeros? Plus or minus 3. And then 5. Now, if you recognize that you knew that grouping was going to work right away, and you knew that you were going to be able to factor out an x plus 5, could you just synthetically divide it by negative 5 and bring the terms down real quick? If you wanted to, if you see that ahead of schedule, is there anything wrong with doing that? No. So if you have a calculator, if I have a change of heart at some point, right? And I allow you to use the calculator to find your starting point, would you just say, oh look, there's one at 3, and then I would use synthetic from there. Using the idea of where to start, it helps you out. It's just little things like that. It's the little things. So like I said, don't write this out, but if f of x is a polynomial of degree n where n is greater than 0, basically any nth degree polynomial greater than 1. F of x has a 0 and at least one root. It basically states for every x, there's going to be an answer. That's what that means. Yeah, I snapped and it just kind of. All right, take a minute. Take a minute. Find all the zeros in these two. However you feel like trying to do it. Find all possible zeros. You guys are probably already through the first one. I'm also going to guess that you guys probably grouped that one. So if you group that one, you took out an x squared and an x plus 3. Took out a 16 and an x plus 3. So your terms were an x squared plus 16 and an x plus 3. That generates zeros at plus minus negative 4. Negative 5, plus or minus negative 4i, excuse me. I'm sorry, did I say plus minus negative? Plus minus 4i.
Negative 4i.
And then negative 3. But what do you do with the other one? What is it? Yeah. What's the first rule? What's the first rule of factoring?
I feel so stupid.
And you know why? This is a huge thing that most people tend to forget. When you do those, is it okay to have a 0 at 0.
Yes.
Yeah. It's perfectly fine to have a 0 at 0. So in this case, my first order here would be to take out the x. Then I have an x cubed, 6x squared, 12x, and 8. As I'm looking at that, I'd like to think that I could group it, but I can't. Am I fair with that? So we start with our synthetic. We know that we have a 0 at 0. Okay? Think of this as you factored out your term. So now you still go through the rules of what times what's 8 and what times what's 1. We'll do our plus minus 1, 2, 4, and 8, or 1. And I'm going to do some synthetic. Okay, so you have it at -2. So there's my 2 zeros so far. And now I'm at what times what's 4? We add together to get 4. Two and 2, right? But didn't I just try 2 and it didn't work? Pair of ducks. Yeah, here's 2 ducks. Here's 2 ducks. There's a pair of ducks.
It's right there.
It's a convertible.
It's a duck from the duck boats.
Oh, those are
Oh my
It's an amphibious vehicle.
It's the little.
All
right, sorry. The hitch. That's right. It's not the hitch. It should just be the little propeller right there. Sorry.
Those things are
Not
great.
drawn to scale.
Not
All right. I apologize.
You know, if that fits the
I'm
scale-
sorry.
I mean, the scale is like just ruined.
Yes, that's what's wrong.
We don't know.
Because it's an amphibious vehicle. Don't laugh at me. It's a real thing.
Hey, look at that. You actually wind up with multiplicity 3 times. So you actually have.
We have triple multiplicity. I'm still not sure.
Multiplicity just means it's multiple zeros. Multiple zeros at the same time. Now,
Why do we have to have that?
Because it's communist.
it's just a fancy name.
Oh, okay.
I think I've got. Yeah, because I don't know. Let's do one more because I don't want to go. I'm not going to work backwards yet today. We'll do that tomorrow. Let's do one more, and then we'll work backwards on this tomorrow. I figure working backwards, we could probably sneak it in, but with it being a weekend tomorrow, it might not be. It'd be all right just to do because it takes about to do it right. It would take us about 20 minutes to really understand and go through working backwards. I know we got a couple minutes. It's not enough time, so we'll cut it after this example here about factoring everything out fully and finding out. I should have said find all zeros again. I'm sorry. And then we'll work backwards with this tomorrow because in essence you've been doing it all along. If you know what a 0 is, you can find its term. If your 0 is 3, what's your term? X minus 3. So in essence, I've been kind of working with you guys all along about the relationship between zeros and terms. Go figure. There was a reason that
Like there's a committee that decides
I wouldn't say the size. There's a
that decide the general purposes of what you want to learn and sort of fill that.
that's more or less our department of like what the order and sequence is, and then how it's presented is kind of up to me.
Oh, you have 3. Ooh.
I forgot.
You should include little pictures in the corner of the slides. Like every once in a while, of like a random thing.
I just drew ducks.
No, but I mean like a small picture that's hidden in the corner. Or like hidden in an O or something. No Danny DeVito.
I thought the pictures of like the
If I
ducks
Danny
were
DeVito
good.
inside
I
You want a pair of ducks?
Your ducks were subpar.
I could have drawn some duck foods. They still make duck foods, right? Is that what they call them?
This criticality allows
Duck
for
fruits?
improvement.
They're like what? Like
Critical
washes and like leather.
appears to be